Good afternoon. So far we have discussed about the background of dimensional analysis, dimensions, units, dimensional homogeneity, non-dimensionalization, and Buckingham Theorem under dimensional analysis section. So during the last lecture I gave you an example problem to work out. So the problem is to find the 5 groups for the function of lift force, chord length, velocity, density and viscosity of air, speed of sound in air and angle of attack of wind. So let us consider how to solve this problem. So the first step is to find the number of variables involved. If you count them, there are 7 number of variables including the lift force, which is the dependent variable. So our n is equal to 7. The next step is to list the primary dimensions of each parameter. In this particular example, alpha is also a parameter, but it's already dimensionless. So it can be directly considered as one dimensionless parameter or one phi group. So then let us consider the next other 6 variables to list their primary dimensions. So FL is the lift force and its dimension is mLt minus 2. V is velocity and its dimension is Lt minus 1. Same to Vc, which is the velocity of sound in air. Lc is chord length and its dimension is L. Rho is the density and dimension is mL minus 3. Mu is viscosity and its dimension is mL minus 1t minus 1. To interpret these parameters, all 3 primary dimensions are involved, meaning length, mass and time are involved. So our J is equal to 3, that's the number of primary dimensions involved. So by taking the difference between total number of variables and the number of primary dimensions involved, we can have the number of 5 groups. That's by taking the difference. 7 minus 3 gives 4. The number of 5 groups can be formed for this particular example is equal to 4. Next step is the most important and critical step involved in Buckingham Theorem. So that's to select the repeating variables. So in this example we can't select lift force as the repeating variable, as that's the dependent variable. And also we can't select V and Vc together as repeating variables, as they have the same dimensions. On the other hand, it's not wise enough to select viscosity as a repeating parameter because it involves with all 3 dimensions. If you can remember the last lecture, I have mentioned about the guidelines to select repeating parameters. So if you can remember, generally we are not going to select complex variables as repeating parameters. In other words, generally it's good to select parameters depend on 1 or 2 primary dimensions rather than all 3 dimensions. So by considering all these facts, we can select velocity of air, density of air and chord length of the aeroplane wing as repeating parameters. So then we have to form the 5 groups. In order to form the first 5 group, we will consider lift force with all 3 repeating parameters. So then we can write phi1 is equal to FL times V to the power A, LC to the power B into rho to the power C. So then we can expand it with their relevant dimensions. So it can be written as phi1 is equal to mLt minus 2 times Lt minus 1 to the power A, L to the power B, mL minus 3 to the power C. Then you have to equate the exponents of each variable to 0. By doing so, finally you will end up with answer like phi1 is equal to FL over rho V squared LC squared. But as you all know, the dimensions of L squared or LC squared is equal to the dimensions of area. So instead of LC squared, if we substitute half times A, nothing will happen to the dimensions. So half is kind of constant and it's dimensionless. Area has the same dimensions as L squared. So by substituting so, nothing will happen to the dimensions of this particular equation. So by substituting, the modified phi 1 becomes FL over half times rho v squared into A. That's called as lift coefficient. So our first phi group is lift coefficient. Secondly, we will consider the viscosity with all three other parameters, other repeating parameters. So by following the same procedure as before, we can write the phi 2 with their respective dimensions, and then finally you will end up with answer as phi 2 is equal to mu over rho v LC. If you interchange the denominator and the numerator, or taking the inverse of this phi 2, that modified phi 2 becomes rho v LC over mu. That's called Reynolds number. So our second phi group is Reynolds number. Thirdly, we can consider VC with other three repeating parameters. As you all know, VC has the same dimensions as velocity. So by doing the same process, finally you will end up with phi 3 is equal to V over VC. That's called Mach number. So third phi group is Mach number, and fourth is alpha, which is already identified as non-dimensional group. So finally, now we have all 4 phi groups for this particular example. So it can be finally written as functional relationship, as function of FL over half rho v squared A, rho v LC over mu v over VC, and alpha is equal to 0. Or in other words, function of Froude number, Reynolds number, Mach number, and alpha is equal to 0. So far we have worked out 2 examples, and hope now you are comfortable with applying Buckingham theorem to calculate dimensionless groups. So however, one of the fundamental limitation of this method is that prediction of exact mathematical form of the equation is not always possible. If you can remember the previous example, we have to interchange the terms to make it as Froude number or the Reynolds number. So we can't have the exact form of the particular non-dimensional group by using this method. So that's the main drawback of this particular method. However, simply this method forms dimensionless groups by considering the forces acting on a fluid particle, such as pressure force, friction force, gravitational forces, surface tension, and all other forces. So this table shows you some already defined, commonly using important dimensionless parameters. Reynolds number, which you have already derived from your previous example, that's inertia force over viscous force. Euler number, that's pressure force over inertia force. Most of these parameters are ratio between forces or stresses. Reynolds number, Euler number, Froude number, Weber number, Mach number, friction coefficient, drag coefficient, lift coefficient, moment coefficient. These are some commonly using important dimensionless parameters used in fluid mechanics. But the dimensionless groups are not limited to these numbers. There are several more. These are some examples for commonly using dimensionless groups. So that's all about non-dimensional formation of non-dimensional groups.